Hello everyone, welcome back to my channel. So in this video we are going to learn about the basics of systems. Okay, so what is system, and two types of systems also. Okay, so in the classification of systems, two classifications we are going to see in the same video. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So a system, so generally a system is any physical device which generates output for any given input signal. Okay, so if you give any input signal for a system, it generates the corresponding output. Okay, so the block diagram of any system will be like this. This is y of t and this is x of t. Okay, so x of t is called input. It is also called excitation, or it is also called cause. Okay, so this is same. Input, for input we'll call it as output. For excitation we'll call this as response, and for cause we'll call it as effect. Cause and effect relationship, or excitation response relationship, or input output relationship. So generally we'll call input and output. Okay, normally. So y of t can be written as t of x of t, where this t represents transformation. Okay, so we are transforming the input to be appeared at the output of the system. Okay, so some transformation we are applying on the input signal so that we are getting the corresponding output. So this transformation may be amplification, for example. Okay, so for example, amplification in the case of amplifier, attenuation in the case of attenuator. Okay, so some transformation we are making on the input signal so that we'll get the corresponding output signal, that is transformed output. Okay, so this is about system. So two important points here is if system, if you know input. Okay, so if input and output. So if you know input and you know what you also want from the system. Okay, so that means if you know the input and also output, and you have to design the system. So if you know if input and output are known, and system has to be designed based on input and output. That means you know the input and you also know the output. Now you have to design the system. Then that process is called as synthesis. Okay, synthesis. If you know input and system, now you are going to derive the output. That means what the output you are going to have, you are going to derive the output. Then that process is called as analysis. That is why we are going to use the word analysis more, because we know input and system in most of the cases, and we are going to see what is the output from that system, so that we'll call that process as analysis. Okay. So in continuous time cases, in continuous time signals, so input is continuous x of t and output is also continuous y of t, the equation which relates input and output, equation which relates x of t and y of t is called as differential equation. Okay, so in continuous time signals, in continuous time systems, the equation which relates input and output is called as differential equation. So it will be of this form, like 2 into d square y by d square y of t by dt square plus 10 dy of t by dt is equal to x of t plus 2. Okay, so it will be of this form. This is called as differential equation. Okay, so in continuous time signals or continuous time systems, the equation which relates input and output is called as differential equation. Similarly, in discrete time systems, any equation which relates input x of n and output y of n is called as difference equation. We'll call that as difference equation. Okay, so remember these two words, differential equation and difference equation. We'll use this in Laplace transform and we'll use this in Z transform, because Z transform is the analysis of discrete time systems. Laplace transform is the analysis of continuous time systems. Okay, so difference equation, any equation which relates input and output of a system in discrete time is called as difference equation. It will be of this form, like y of n minus 1 2 into plus y of n minus 2 is equal to x of n plus 2 into x of n minus 1. So this is called as difference equation. Okay, so this is differential equation. Okay, so next we'll see classification of systems. Okay, so classification of systems, there are different types of systems. Okay, so we'll learn one by one. So we'll learn 2 of them in this video, and remaining videos we'll learn the remaining types of systems. So first classification is very simple classification, continuous time and discrete time systems. Okay, continuous time and discrete time systems. So very simple. So if your input is continuous, that is x of t, and output is also continuous, input is continuous and output is also continuous, that is y of t, then that type of system is called as continuous time system. Continuous time system, that is y of t is equal to transformation of x of t. Okay, so if input is continuous and output is also continuous input will produces continuous output. Such type of system is called as continuous time system. And if input is discrete, that is x of n, and output is also discrete, that is y of n, then that type of system is called as discrete time system. Similar, y of n is equal to transformation of x of n. Okay, so that is discrete time input will produce discrete time output. So discrete time input will produce discrete time output, then that type of system is called as discrete time system. Very simple classification. Okay, the second type of classification is lumped parameter and distributed parameter system. Distributed parameter systems. Okay, so lumped parameter and distributed parameter system. Okay, so in lumped parameter, so we'll discuss around points. So in lumped parameter systems, the every component is lumped at one point in space. And in distributed system, so these since there is only one point in space, they are different. They are described by ordinary differential equations. Ordinary differential equations. That is one dependent and one independent variable, so they are described by ordinary differential equations. So distributed parameter systems. In distributed parameters, the functions are the signals are functions of both space and time. Okay, so they are described by partial differential equations. Okay, so if length is very much less than lambda, then that type of system is called as lumped parameter system. This is the second difference, lumped parameter system. If L is very much greater than lambda, length is more than lambda, then that type of system is called as distributed parameter system. And the third difference is circuit theory. Circuit theory is used to study lumped parameter system. Okay, and field theory is used to study distributed parameter system. These are the differences. In short, what can we say? That every electrical circuits which you are learning using R, LC, diodes, transistors, everything. So okay, all electronic and electrical circuits which you are seeing comes under the category of lumped parameters, because their length is less when compared to their wavelength. Okay, and in distributed parameters, example is transmission lines. So their length is of very high range when compared to its wavelength. So field theory is used for transmission lines. That is why we will study electromagnetic field theory. Okay, so field theory is used for transmission lines, and in transmission lines, to represent the voltage and current equation, we will use partial differential equations. And in networks concept, that is in network theory, we will use ordinary differential equations to solve transients. Okay, so these are the differences between them. Ordinary differential equations, example is network theory. Okay, so circuit theory is used for lumped parameter systems. That is the network theory, which is consisting of all the passive components and some active components. Similarly, field theory is used for distributed parameter systems like transmission lines. Transmission lines is the best example for distributed parameter system, and normal circuit theory is example for lumped parameter system. That is why every component is at only one point. It will show the effect only at that particular point where it is connected. Okay, so such type of system is called as lumped parameter system, and it shows the effect along the length, total length. Then that type of system is called as distributed parameter system. Okay.